operations, add, subtract, multiply, and divide until you get to calculus, and they add those two. And those two are inverses of each other. They do and undo each other. Okay, I'm sure you remember that from your calculus course, which you took 20 years ago. So the next one is building rules to represent functions. Where does that begin in the T? So I'm going to give you 3 seconds.
Kindergarten.
I'm going to give you 3 seconds.
That was fast, 3 seconds.
I think we're Googling it all. Okay, building rules to represent functions. I go over this every summer almost because algebra is my love. Geometry and algebra are my 2 favorite things except for probability. It's also one of mine. So what does that mean? Oh,
Why did I catch your eyes?
because you look like you knew it.
Building rules for, we're on 2, right? Looking at the way that something works and saying, okay, this will continue to happen.
Okay. Building rules to represent functions. Francis?
Input and outputs?
Input and outputs. It does have to do with input and output tables. Where does that begin in the TEKS? What grade level? Is it least anybody?
I think it's
You put input and output tables
They
in?
put the little box instead, we use variables, they use the box.
Exactly, the little magic machine.
Yeah.
The little magic machine, it goes through, comes magically, comes out. So it does begin in kindergarten, okay?
There you go.
So they may not call it functions, but that's what they mean. They may call it just a rule, right? Okay. So abstracting from computation, what does that mean? It could involve word problems. So you know what computation means? Adding, subtracting, multiplying, dividing, and you're doing it, and you're doing it, and you're doing it, and then what? Mr. GT?
Could it be like fact families in lower grades? Like, 2 plus 3 is 5, so 5 minus 3 is 2.
It could also involve fact families. You're absolutely right. In the lower grades.
grades.
Yeah, that's a good thought.
But couldn't it also be like putting it into words? Like, I know my 3rd graders have a hard time, they can do the computation, but when they see it in a word problem, taking those numbers and doing that. So inversing that by taking the numbers and putting it into a word problem.
Thinking of their own word problem? Yeah,
That
it
goes
could.
well.
But the word abstracting, are they abstracting from that? Yeah, Jen?
Basically the thinking of it, seeing what they want to do, or, I don't know, I have a big problem with this. Whenever I see an equation, I try to explain it to my students, I actually see what I'm trying to do. So if I have 2 groups of something, I actually like start picturing 2 groups. And so that's where I go into my pictorial after, if they don't have something for them to actually manipulate with in front of them. So I think that they're thinking outside the box, not just a direct, is my way of thinking of the abstract portion. And then they're doing the computation while they're doing it.
Okay, because
So it's
abstracting
building
is
into that
mental.
next, it's more of seeing it and doing it.
At first I was thinking, because I think abstract, and we always say the trick, so then I was like, oh, like getting the formula from.
You know, you're closer than you think, and you're closer than you want to be. I think about how you said that. Because we don't want to give them the formula. But where did the commutative property come from? What is the commutative property, Rochelle?
Oh.
Don't look at me.
Don't look at her.
Yeah.
Go back to four.
Yeah.
Yeah.
So it changes the order. Did that just come down from heaven?
Is it creating proofs?
It could be creating proofs, but right now we're talking about commutative property. So did somebody just, some mathematician just wake up someday and say, oh, there's a commutative property. I'm going to write it down for everybody to learn.
She asked, what is it?
Kind of fast.
Patterns, yes. Throughout centuries, mathematicians noticed that in addition, when you change the order, you actually get the same answer. So they abstracted that commutative property from lots of computation. And it took, long time. And then there's other properties too that were done the same way, all right? So those are the habits of mind for algebra. This is all from last summer. You should have all memorized it, except for the new people. y'all get a bye, okay? Until next week, yeah. So, then just a little bit about what Laura and Dr. West have already talked about, and that's the order that you should teach in. Anytime you teach a new concept, you should start with what? Canvas, I bet you know already. Concrete. And then you go to the pictorial. See, I'm doing it again, I'm not waiting. And then you go to the what, Kim?
Abstract.
The abstract. Now, Dr. West said in science, when they draw the picture themselves, she considers that concrete. In math, I did not. If it's a picture, it's pictorial. Concrete is something you have to move or touch or move your own body to do something, okay? So first you have to start with the concrete, then you go through that pictorial, and then you go to the abstract. Now, words are abstract. What I'm doing to you is very abstract. Symbols are abstract. Algorithms are abstract. Equations are abstract. All of that is abstract, okay? But the pictorial stage is so very important. I'm sorry, I'm pacing. The pictorial stage is so very important because they can draw on those star tests. So if they're used to using their manipulatives, and they've done problem after problem with manipulatives, and they have a problem similar to that on the STAR exam, they can draw a picture of those manipulatives to help them figure that out, can't they? Is that considered cheating? It is not considered cheating. The state of Texas doesn't care what you write in those books as long as it's not vulgar. Okay? So they can draw anything they want. So here are some types of representations. There's manipulatives, there are oral or written words, there are symbols. I know I changed those all to uppercase letters, but evidently they're not. So there are symbols, pictures, diagrams, tables, and graphs. And we're going to do a lot of those today, once I start this activity. Okay, this is all just to catch up with the people, to what the old people knew and loved and learned last summer and have tattooed into their heads. Yes, retained is a nice word. So, and then we talked about fractions. There are 3 ways to represent fractions. There's the area model, and we did that with pattern blocks, remember? Yes. And then there's the linear model, and we did that with Cuisenaire rods, remember that? We all love Cuisenaire rods. And then there's the set model, where you do counters. And you have to be careful in lower elementary not to introduce a set model until the kids have conservation of number. So, conservation of number. Let's see. Actually, do you know what conservation of number is? Are you science? Well,
Going back like, is it like where if you do it to do something to adhere, you have to do it?
it's kind of like conservation of matter. Conservation of number is if you have, suppose we have 3 items right here, and they're close together, like this, and the child sees that's 3 items. And if they can just look at it and say that's 3, then they have supertizing in their head, and they can supertize. But then we spread it out, and the child looks at it, and you say, is that more or less? I think it's more, because it's covering more area. So they think it is more because it's bigger. Okay? So that's conservation of number. So they have to have conservation of number before they can use the set model, because the set is working with individual little chips or cubes or something. Okay? All right. So then we divided fractions, and we loved this, remember? We loved this. It was. Sometimes it's division means it goes into. Remember my teacher who said it's a gazenta problem? And I had no idea what he was talking about. He said gazenta. Okay. So sometimes it's a gazenta, and sometimes it's a how much of or what part of. All right? So we had something like this. 1/2 will gazenta 6. Okay. How many times does 1/2 go into 6? Let's count it to 3. Melissa?
12 times,
12 times. How did you get that?
because the last time I did it wrong. And I remembered.
How did you get that?
Because I want to know if I have 6 halves, how many times, how many I would need to make 6 whole items. And I know it takes 2 halves to make 1 whole. So I multiplied 6 times 2.
Very nicely done. Okay. Usually you talk about money here. How many half dollars do you have when you have $6? The kids will get that and adults do too. All right, so that's a bazenta. And then we have this. 1/2 divided by 3 halves. Hang on just a second. 3 halves is larger than 1/2. So will 3 halves go into 1/2? Not really. So what we want to know is what part of 3 halves is in 1/2. So using pattern blocks, the trapezoid represents 1/2 if the hexagon is your 1 whole. Okay, this is pictorial. The trapezoid is 1/2 if the hexagon is 1 whole. So this is 1/2. How much do I have represented here? 1 and 1/2. So I have 3 halves. So what part of 3 halves is in 1/2? That means 3. Jen?
1/3.
1/3, how did you get that?
When I'm looking at this, I think to myself, how many groups of the divisor can I make from the dividend? I can't. But I can make a fraction of the group. What fraction of the group is my dividend of my divisor is 1/3 of my divisor.
Okay, it is 1/3. So the answer to this is 1/3. And if you don't, if you want to check me using that algorithm, you're welcome to. Okay, what is the algorithm for division of fractions? Inverse and multiply by the reciprocal. So we would flip the 3/2 and get 2/3 and multiply and get 2/6, which is simplified. Right? Right. And then we did this all last summer, remember? And some of you, I don't remember who, said you actually took this and used it, I think it was Jen, took this and used it in your classroom.
For star review.
For a star review. So then we did it on a number line. Okay? So here's the same problem. 1/2 divided by 3 halves. And we know it's going to be 1/3. We already marked that problem. So which arrow up there represents the 1/2? The red one. Which one represents the 3 halves? The white one. So we're saying that the red one is 1/3 of the white one. So 3 of those red ones should fit in that white one. Okay, so there's another one, and there's another one, and they were really pretty colors before I had to change the background to black. Okay, so you have to trust me. All right, and then we did a whole lot of modeling, pattern blocks and linear rods, and then we worked stated problems, which we loved. Okay, we worked 2 of them. Remember this? Okay, we worked 2 of them. But today, this is just a review, so today, we're going to start with algebra, all right? So once you get your pattern blocks, I'm going to divide you in a jigsaw this puzzle out, okay, this problem. And some of you will be working one problem, some of you will be working another. We're going to post it on chart paper on the wall, that's my thing. And then we're going to see if we find any patterns, all right? So girls, can y'all pass out those pattern blocks? And for some reason, somebody put color tiles in there, so be sure they're pattern blocks and not color tiles. You're going to have to share some of the bags, too. I don't have 8 bags, so we have 6 or 7 bags. there, some of you will be working with other shapes in the pattern box, all right? So go ahead and get the pattern box out and let the scientists see them if they haven't ever used them before. Okay? So get the pattern box out for the scientists to see.
Enough, I think.
The problem is, I'm more with them, she has a sport, so you can tell
Or you can take it on the same. So you just keep adding it like this. Yeah, but then you take one away. Why can't you add
Okay, so science people have now had time to look at the pattern blocks. They are called pattern blocks because we can make really nice mosaic patterns with them, which is how they start with them in pre-K and K.
Really quickly, I'm gonna be passing around these centimeter cubes as well. Make sure that at the end, you don't put these back in the bag with the pattern blocks. So keep these separate.
Right, the pattern blocks are mine, my personal pattern blocks. The centimeter cubes belong to Nick's. So I can't take the centimeter cubes and they cannot have my pattern blocks.
Oh, FYI, on the centimeter cubes, I have a big jar of those myself. They also equal exactly 1 gram.
They do.
Yes.
They do.
And the wooden piecemeal rods
Yep.
are equal mass. So if you're doing algebra, you have wooden piecemeal rod sets.
Are these also in millimeter?
They are. Yes.
Oh, yeah.
everything I have, you might
Even the meter, you
have
can probably do this.
There's a long way. There is.
Get a handful of
But my other guy,
So Dr. Brown, if you wait, for example,
I have.
if you're in medicine next year
I
like
can't hear her because I'm really old. I can only hear one person at a time and Denise has support.
So those that are ready to join Mix for next year, you will get pattern blocks, Cuisinart rods.
So
If I use them in my training, you will get a set of them, not a classroom set,
Just one.
but a set for you. Yes, anything I use in my training, you will get a set. So since if you're new today and you're coming back, then you will get a set of pattern blocks. Okay, if you don't come back after today, you don't get them, all right?
Oh, and they belong to you.
Yeah, they belong to your school, not the district, not the district. All right, so are you ready for me to explain what we're doing? Okay, yes. I'll wait till you are quiet. See, it works for kindergarten teachers so beautifully. Yes, I went to my granddaughter's kindergarten class just to observe the teacher. You know, kindergartners, chatty, chatty, chatty. So they were up at the carpet, she was sitting in a rocking chair, and she was gonna read books. Chatty, 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 she folds her arms and says so sweetly, "I'll wait." They hushed immediately. I was amazed. Best kindergarten teacher I had ever seen in my life. I love that woman. And my granddaughter really needed her because she was extremely shy. And had she not had that type of, if she had one that shouted like I did, she would not have functioned well at all. All right, so going on. In this situation, a restaurant has a square table. How many people can sit at this square table normally, not adding chairs, you know, and doing all of that? I know I want to call you Carolyn, but you're Catherine. Yes, ma'am. 4? 4. How did you know that?
Because the square has 4 sides.
Square has 4 sides, so one person can sit at each side, okay? So this is stage 1 in this restaurant, all right? And you're not all going to be working with squares, so you don't have to copy this down right now. Okay. So if we have a larger group that comes in, and we want to see more people together, they're going to push two tables together, and they're going to be pushed together like this, all right? So would you model with your pattern blocks this stage 2 and put the people on there? I need to remind you of some of the rules for mix. If you're the math teacher, you cannot tell anybody else at the table any of the answers, okay? You can ask him, you can ask questions so that they figure it out on their own, okay? But you cannot tell them anything, Clinton. You have to completely quiet. Which means if you're the math teacher, you don't want to move their cubes for them. You know, this is not a good question. Don't you think this should be over here? See, that's not a fair question. That's a you telling them what to do question.
Hey, he's
Right.
like that.
Okay, so, let's see. Johnny, how many people can sit at two tables in this, pattern?
6.
6, very nice. How many agreements are raise your hand? Okay, nice. All right, so now I just want to review the blocks to make sure you all understand. So I want everyone to hold up a yellow hexagon. Nice. Now, Rochelle, tell me why that's a hexagon, or tell me the attributes of a hexagon stick.
It has 6 sides and 6 vertices.
Good. 6 sides and 6 vertices. All right? So now hold up the trapezoid. Hold up the trapezoid. The science people don't know it, will you please help me? Okay, so Quentin, tell me the attributes of a trapezoid.
It has 2 parallel sides.
Exactly.
Oh, okay, wait, it has 4 sides total. 2 of the other sides, 1 set is parallel. And 4 angles, 2 sets of which are previously equal.
She just said.
Yes. You're good.
Okay.
It is a quadrilateral.
Oh,
Quadrilateral that has only 1 set of parallel sides. This one happens to be an isosceles trapezoid because the 2 sides that are not parallel are congruent. There are other trapezoids.
So should we describe this as a regular hexagon?
That's a very good question. Should we describe that as a regular hexagon?
Yes.
Sorry. You answered your own question. That is right. And I noticed Laura did that one time this morning. Did y'all catch it? She asked a question and there was complete silence. So in her explanation, she told me the answer. And I don't guess y'all caught it. Don't answer your own questions. And if you know the answer, because you teach math, don't answer my questions. All right, so now, since she brought that up, that is a regular hexagon. Why, Pam, is that a regular hexagon?
She asked about chocolate problem.
No, she asked about the hexagon.
It's a regular hexagon because all the sides are congruent.
Right. Regular figures in math have all sides congruent. All sides congruent. So is the square a regular quadrilateral? Yes, all sides are congruent. And also all angles are congruent. All the angles. Okay? Now I know in science, a regular figure is a figure that you have a formula to find the volume of. Okay? That's not the way it is in math. In math, they have to have congruent sides. So in science, a rectangular prism, because there's a formula to find the volume, is considered a regular solid. But in math, a rectangular prism, any old rectangular prism like this table, is not considered a regular prism. A cube is, because all the faces are congruent. Yes, ma'am.
So I think now maybe might be a good time to talk about the dictionary, maybe? Or
Not right now, because I have limited time. Because science always runs late, so I'm used to having my time truncated. All right, so hold up the rhombus.
Diamond?
Okay, so most of you are holding up the blue shape, that is a rhombus. So, Sarah, tell me some attributes of a rhombus, please.
It is a quadrilateral. This is a quadrilateral that has two pairs of parallel sides and two sets of equal congruent angles.
Almost. It is a quadrilateral. Please don't talk, Rachel. It is a quadrilateral. It does have two parallel sides. That last sentence was just almost right, but not quite. What did you say, Sarah?
It said it has two sets of congruent angles.
You said sides.
Oh, I meant to say.
Well, either way.
Sorry.
Let's talk about sides. Two sets of congruent sides. Okay, that's true about a rhombus. It's also true about other parallelograms that are not rhombi. Okay? So there's a special thing about a rhombus that you have to know. And what is that? And looking at it, Sarah, what do you think it is?
I would say it has to do with the angles.
Now we're talking sides.
Okay.
Can you measure those sides? Do you have a ruler to measure with? I don't want you to use the ruler if it's there. What could you use to measure those sides? You could use the square, you could use the green triangle, measure those sides and tell me what you figure out about them. You discovered they're all congruent. They're congruent. They're congruent. So it's a quadrilateral with opposite sides parallel and all four sides are congruent. That is a rhombus. That's a rhombus. Okay.
Is there a regular rhombus?
I was going there. But thank you. That's okay. And
We have a question about our regular hexagon.
hang on a minute. We're talking about, Pam asked the question, is the rhombus regular? I'm thinking now, I'm counting to three. You want to answer?
No.
The answer is no,
Okay, because?
because even though the sides are congruent, the angles are not.
Very well said. The sides are congruent, but to be regular, the angles also have to be congruent. So what is the regular quadrilateral? Hold it up for me. You know what it is? Hold it up.
Oh, quadrilateral. She got me. She got me with the small part. I wasn't.
Has to be the square, because all four sides of a square are congruent, all four angles are congruent, okay? All right, so, all right, going back to this problem. Some of you are going to work this problem using the square, and I will assign the tables that use the square. Some of you are going to work this very same problem using the triangle as the table. Okay? And the reason I have stage 2 and stage 3 up here for the triangle, because I want you to know how I want you to put it together. I don't want it vertex to vertex. Okay? Some of you will be using the, what is this? The rhombus, nice, the rhombus. Okay, and I want you to use the blue one, not the tan one. There's a tan one in it, okay? And you would put it side by side like this, okay? Some of you will be using the trapezoid, and it will be put together like this. Some of you will be using the hexagon, and it will be put together like this, okay? You notice they're all linear. We're putting them in a line. We're not making a beehive or something from the hexagon, okay? It's a linear problem we're working with, all right? So here is the problem. You are going to, with your manipulative, let me back up. With your manipulative, you're going to actually build the first 5 stages of whatever you're assigned. Okay, so I built the first one here with the people. Over here, I don't have the people, but you're going to build it with the people. That's what the centimeter cubes are for, all right? So you're going to physically build, I want you to work the problem as a child. I almost said act like a child, but I don't want you to do that. I want you to work this problem as if you are a student. So try not to use your teacher knowledge. Try to figure it out as if you are a student, okay? So you're going to physically build with the manipulatives, putting the people around them. And don't mess up stage 1 and 2 to build stage 5. Okay, 5 stages illustrated. Yes, ma'am.
We need a whole lot more money.
Yes.
I'll pass it out.
I'm on it,
I know.
That's my fault.
I'm on it.
Wait a second.
I already did the math.
So now I'm going to assign the shapes, all right? I'm going to assign the shapes. So I want y'all to do trapezoid. I want y'all to do square, triangle. Y'all can do the hexagon. Y'all can do the rhombus. Y'all can do the trapezoid. Y'all can do the hexagon. Yay! And y'all can do the triangle. Assign a rhombus.
As a group or as we're starting with the I don't know. So my kid was in your room and just observed. Make sure you
So I haven't told you what you're going to do yet, right? I mean, I've told you you're going to build the first 5 stages, all right? After you build the first 5 stages on chart paper, you're going to make a drawing of the first 5 stages of the table and the people. From there, you're going to create a table describing the connection between the number of tables and the number of people that can sit at the tables, okay? And then you're going to graph that, right? And then you're going to have a verbal description and a rule, a function, for this relationship between the number of people and the number of tables, okay? Now, to do that on your chart paper, you're going to have to take your chart paper and make a 4-quadrant fold. Okay? So y'all want to go ahead and distribute the chart paper and we can make our 4-quadrant fold, ladies? So Alexis is going to give you some chart paper.
You run out of people.
Sometimes a table of 4 wants to work in pairs instead of in 4s. So if you want to work in pairs, you need to tell her that she'll give you 2 sheets of chart paper. Okay? Sometimes, you're listening? Sometimes with a group of 4, one of the participants decides to sit it out and let the other 3 do all the work. If I see that, I will put you in another.
We got it. We got it. She won't work with us.
I already know the equation. I know you do, not for all of them. Which one are you doing?
No, you can figure it out for all of them, they're based.
Which shape do you have?
The triangle.
You come up here, we're going to the hexagon.
We got you. Next time you shower, Actually, like this? No. Here, wait, here, never mind.
Upside down. All right.
You can do it. No offense, but that was a very different. You can go like this though, right?
So y'all are not Is it different if you assemble
Well, she just doesn't want you to was it too long? I guess my you know, like if you say that, soft, zero, that, like, has to do with, she asked me, what are you doing? I said, I don't know what it means. She's testing it. Oh, I didn't. Yeah, so, the one that are already at level.
Together on that,
So it's not a good thing. It's not what you want to do. I did one for my
This would be better if you had it.
Yeah. Should I recess? Watch attention, probably a little bit better.
Oh, the same. These people? They're the waiters.
She is beautiful. I can't do that.
If we were at a really cool place, it would be really cute.
I didn't even take a roller. Oh, it's that kind of restaurant.
I'll be in there. So this is over here.
What did you say? Oh, we have more quadrants. Okay. Yeah, we have to be right. So she was already backwards. Audrey wasn't to the side. See where we need to go. Oh, she wants us to split it.
She represents a draw, you know, table, the table, and grab everything, right across the box.
It was like April, beginning of April,
It's sticky, it's
we got the back end of it.
So here.
Nice.
How big? And then here.
Where it's like different patterns, like here you apply.
Grass would be here. The table would be like
But together you have to divide it. And I was like, a
How many people?
What's your Good job, cheesy kids.
You're gonna draw all
The
the way.
minis individually.
Okay. So, I draw.
Just do it.
Stay here and hide art.
Hey, let's go home.
Yeah, ours is on a Sharpie.
Oh, 5?
Well, we didn't treat it as
Oh, wait, did you have yeah.
Sorry, what did I say?
Oh, I went to Bay Area.
what was the first person teacher?
Melissa. What is that? Why is it not drawing?
Okay, what changes? She's oh, yeah.
Well, I see what we're
So this one here, not Brenda.
She didn't tell me it was still wet.
You need to go back into.
I am going to next weekend. I told them earlier, I was like, plan on being here for Friday. I told them plan on being here for Friday, but they potentially leave. If you tell them it's gonna be that day.
So did you see that? Is there a party here?
I know it's not that, but they need to make a commitment to like, I will make that day.
She doesn't need it.
No, you don't make them.
I thought that.
There was 2 tables. Can't like keep your whatever against students. Be here that day. Be here in the morning, do tests. They'll be all over the place. Then it's like, oh, actually, something else.
4, right? Okay. For the third table, we'll have 5 to go. No. So what's happening here is it's increasing by 6, so 3 to 4 is. It's increased by 1. 1, right? So here happens.
And admin, all of the,
How much is it increasing from 1 to 3?
doctor and drop off could have other.
2.
I know.
5. Okay. So you're
That way,
constant.
looking at
No matter what, you're gonna have.
And I'm gonna, whenever the participants are gonna go down and go, check out the questions.
So you have
I'm gonna tell all the people that meet with me,
what should be your
kind
number?
of overview, like their requirements for the project.
What's your change?
Get any other contact information that we, and they have received it.
Or if you continue your pattern. Wow. That'll be 5 more.
Or we can't have 0 tables.
You're thinking of the 2x.
Yeah, one day last time, I would say people, right?
I wasn't there to train. I was pregnant.
I would have -1 too. You know, me too.
No, that'll go on the drop-off.
No, I was there.
Well, cold number does include 0. So not even 1.
You wanna write that?
And so then it went different colors?
And that's all. We can leave it on the table. We can say something later like that. We'll clarify it for all. Favorite part of the year.
So you're gonna stack at the table. It's 11. Is it 4? So it's 9 or 10.
Yes, I know that's a little lot.
40, I'll tell you 3 in the middle. 4, 8, 3, 14.
every time you have an activity or no,
That's just a little bit of oh, it's title.
Should be 17, yeah. Yeah, it should be 17, yeah, I don't want my table to be
I was checking the email.
Oh, dinner. I love dinner. Dinner
Once you come out, everybody has a title. On Star, the title is bottom. So,
Didn't be able to see something. I know, you have black.
Do not cross it out. Okay, I was just like,
I really need to like ask them about it. Which one was it? Oh, what?
I don't know why I did that.
I wish I had her number.
Because I did the X and Y.
Like her, we you both discovered that we both have full recognition. And it's sort of me. See, that's all. See, my mom can't remember her spirit, she had a broken down here. Mine's just horrible.
So you're saying this, what do you want to jump on? What did you have to do to that? What did you do?
Yeah, because I can't do 8, 10, 12,
What else?
so we can do 3, 6.
Do not connect the line. Or right on.
Why not? So if I was 15,
A number of people, a number of people.
So for every school,
yes, I mean, the number. So what was that?
That's what I would say, like,
So you're going to be like, yeah, it represents what? So 2 and 5 10 represents what? 2 and 5 10 is $500. Okay, so here, 1 and 5 10 represents what? So say that number again. The 1 for people.
See how many groups you have. But what's in one group? I sort of just that's it, yeah. Leave your relationship parts, which is higher level. No. You can actually, like, I don't know if you're seeing how we get over and over and over.